A client met his banker to discuss opening a restaurant in a busy airport. In us, he found a partner that understood the importance of reaching for the sky. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hi there, thanks for joining us. This is Space Nuts, the podcast where we talk everything astronomy. Well, not everything, because that'd take us billions of years, but we talk about a few things. I'm Andrew Dunkley, and joining us, as always, is astronomer Fred Watson. Hello, Fred.
For another billion years, I'll be with you, Andrew. Don't worry.
Yes, indeed. Microseconds, maybe. Now, in this episode, we're going to look at Saturn's ring formation. We're also going to talk about the inflationary epoch, which, believe it or not, has come from a question. But first, we're going to talk about something we talked about last week. We talked about the dinosaur Asteroid and how they sort of surmised that the effect was to actually see the temperature on Earth increase, and that played a big part in killing off the dinosaurs. But that was only one of 2 papers that have been released on effects of the dinosaur asteroid. Another paper suggests something just as fascinating. What's the story here, Fred?
I think this is a really interesting one because, we turned one piece of common wisdom on its head last week. This week we can turn another on its head, although this is fairly common knowledge, and that is that the dinosaurs are still around because the feathered birds that we see pretty well everywhere on Earth are small flighted dinosaurs. They have so many features in common. So the distant descendants of those dinosaurs that disappeared 66 million years ago are still around, and they fly around through the air. But so much is, as I said, is fairly common knowledge that the birds have all the signs of being descended from the dinosaurs. But what is new is some work that has been published very recently that actually shows that only a few species of birds survived the impact, or a few species. Let me put it a different way, a few types of birds, because of course today's species of birds are very different from the species that were around 66 million years ago. But if you look at it on the broadest sense, you can kind of divide the dinosaurs, the birds of the time, at the time of the dinosaurs, into 2 groups. The ones that were tree-dwelling and the ones that were ground-dwelling. And in fact, we see similar things today, and we have a few more. We've got things that live on the sea as well. But it turns out, and this comes from all kinds of, studies of the ancestry of birds, the tree-dwelling birds, not the tree-twelling birds. That's quite a different thing.
It's a very good skill, though, tree-twelling.
Yeah, I think, yes, it probably is. Yeah, it's probably something you do in social media. The tree-dwelling birds didn't actually survive the impact, whereas the ground-dwelling birds did. And so what we see is the sort of lineage in the fossil record and in modern genetic studies of birds. All we see as an ancestry is the old ground-dwelling birds, the ones that wandered around on the forest floor and did their thing down there, rather than things that lived in the tree canopy of the forest 66 million years ago. And why did they not survive? Because the trees were devastated. Yeah. So those forests, were basically in the aftermath of the asteroid impacts, those forests were either decimated by fireballs in the vicinity of the impact, or by the after effects of the impact itself. The first initial effects of probably lots of dust matter and aerosols in the atmosphere, and then the increase in temperature that we spoke about last week. They all contributed to wipe out the forests, and with them the forests took the tree-dwelling birds. So the tree-dwelling birds disappeared, the ground-dwelling birds didn't, and that is the group of species that went on to form today's birds.
And they, over millions of years, readapted, and of course now we do have tree-dwelling birds again.
Exactly, because of the fact that the trees came back,
Yep.
And so did the birds. So the details of this are really interesting, though, Andrew, because what caused the forests to disappear? Well, I highlighted a few things. You can tabulate them almost by saying, well, forest fires initially, but then something I didn't mention a minute ago is acid rain. Of course, acid rain is when you form the acid.
As we mentioned last week, it was like a nuclear winter effect.
That's right, for a short time, followed by the temperature going up because of the amount of carbon dioxide. And that, basically just stops the photosynthesis taking place in trees, and the trees die. So it's pretty grim.
Yeah, very, very grim. And so, yes, one half of the bird population went, and the rest sort of went, okay, let's dig in. And that's more or less it. And there were a few other survivors, I suppose, not bird related. But we look at alligators and crocodiles and the like. They sort of survived somehow.
Yes, as did the mammals.
Yes, exactly.
Mammals survived as well. The small mammals made it through. Extraordinary, isn't it? Can you imagine what it would have been like, doing a TV documentary at the time? What was happening? Just extraordinary changes in the general demeanour of the Earth, if I can put it that way.
What would have happened to humans if they existed at that time?
I don't think it would have been good.
No, and yet here we are.
Yes, here we are.
Facing the same cataclysmic possibility.
Yeah, actually, we've had a couple of near misses as well. There's an event you can trace genetically back. And I think it was roughly, I think we've spoken about this before, 10,000 years ago. There was what's called a genetic bottleneck, where the whole population of humankind seems to have dropped to a few tens of thousands of individuals.
Yeah.
And that's because we all share the sort of same genetic material. So we've had quite a few near misses, but fortunately we weren't around 66 million years ago to see the big one.
Or we'd be missed significantly now.
We would be missing. Yeah.
Yes, indeed. One more thing about the dinosaurs I read this week, Fred, that I thought you'd find amusing. They've been studying fossil records. They found that one of the feathered dinosaurs had dandruff.
Well, there you go. It's a problem I tend not to have these days.
Well, interestingly enough, it is a common trait in feathered birds of today.
Feathered birds. There you go. There you go.
But they've found dino dandruff.
Dino
fossil
dandruff.
Records,
well,
yeah.
If ever I grow feathers, Andrew, I'll look out for that. Thanks for the tip.
You're listening to Space Nuts. I think that's enough of that, with Andrew Dunkley and Fred Watson.
Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated number 1 by Tech Radar. This is the one I use. I've been using it for a couple of years, and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
0G, and I feel fine.
Space Nuts.
Okay, Fred, I guess for a little while now we've been focusing on things happening on Earth with Dino, asteroids and that sort of thing. And we're going to go a bit further out in our own solar system to Saturn and look at the inner moons. Well, what's left of them, I guess, is what we're talking about now.
Indeed, what's left of them. So, yeah, look, Saturn, still a world that is full of interest, particularly following the success of the Cassini mission, which wound up last year. One of the great things about Cassini was it allowed us to study Saturn's moons in great detail. And of course, some of the bigger moons are extraordinary places. Moons like Enceladus with its ice fountains from the South Pole, from a subsurface ocean. And the biggest of Saturn's moons, Titan, which is bigger than the planet Mercury, second largest moon in the solar system, with its methane and ethane seas on the surface. All of those things are extraordinarily interesting. But when you look at the other end of the scale in terms of Saturn's moons, and you're talking about things here that are a few tens of kilometers across rather than thousands of kilometers across, things are almost equally interesting, perhaps not quite as spicy in terms of what they might mean for extraterrestrial life, but nevertheless interesting in terms of the history of Saturn. So a study that I think came out about a year ago looked at the orbits of some of these moons that are actually orbiting within the rings of Saturn. They're odd objects. Have names like Pan and Atlas and Prometheus, very classical names.
Yep.
But generally speaking, they're small and they hurtle around within the ring system. What this study a year or so ago showed was, and this was from looking at their orbits, the orbits of these objects, they're actually only about 100 million years old. And that sounds like a lot, but it's actually within, the sort of timescale that we've just been talking about in connection with dinosaurs. These objects are younger than the dinosaurs. Dinosaurs were certainly around 100 million years ago. And so it begs the question, well, where did they come from? If these objects are young, how did they originate? How did they get to be like they are now? And in particular, how did they get such odd shapes? Because some of them have this sort of flattened shape that's rather like a walnut or a bit of ravioli with a rim around the edge. Pan and Atlas are like that. I think, if I remember rightly, Daphne is as well. Daphne is a curious shape too. Another one that orbits within the rings. These things are only a few, not centimeters, but a few kilometers across, or a few tens of kilometers across. They're very oddly shaped. Another one that's got a strange shape is Prometheus. Prometheus is not quite cigar-shaped, but it's longer than it is wide. It's got a very elongated shape, maybe the shape of an almond or something.
They look like
that.
they belong in the crazy section of the vegetable department.
Yes, that's right.
Like really shonky potatoes.
Yeah, with a fancy name and a fancy price. Yeah, that's right.
Yeah.
They don't belong there. They belong to Saturn, but the interesting thing about the point I'm trying to get to, despite my insistence on wandering around the houses in this story, is that it turns out that collisions between an earlier generation of moons around Saturn would have produced these objects in these orbits, and really very nicely, this comes from modelling that's been done by scientists in a number of different institutions, most notably in France and Switzerland, that the modelling actually demonstrates that you can get these weird shapes from collisions. So what you've got to imagine, 100 million years ago, there were other moons going around Saturn, and their orbits became unstable. They started running into each other. And when they had these cosmic pileups, the byproducts were these tiny little moons, sometimes called moonlets, that we see today, whose orbits really started then. And that's how you can work out when these collisions happened. But the strange shapes that we see today were actually produced in these collisions. I think the research has been led from the University of Bern in Switzerland, and it's quite interesting that the models that they were building of what would have happened to create these moons. Usually, when you build models and look at them in detail, they start moving away from reality. But they had the opposite effect. The more detailed the models they made, the more they resembled the effects of, the effects that we see today, the real objects out there in space.
So what they're saying is that what we're seeing happening to the moonlets in Saturn could be an explanation as to what's happening in the wider solar system, wider universe?
In a way, that's true. So what I guess the bottom line in this study is that when you add in all the details that you know about in terms of things that have happened to a particular system, and here we're talking about the Saturnian system over a long period, and it includes details like the fact that Saturn is not a solid object. It's got a core. It may even have fluids in its inner regions, which would have tidal effects. When you add all these things in, you get something that bears a strong resemblance to reality. That's how astronomy works. And as you say, you can apply that on the very largest scales to the solar system as a whole, to the galaxy, and indeed to the universe as a whole. And it's basically how we progress our knowledge. Sometimes we bark up blind alleys. Sometimes we get things dramatically wrong. But generally speaking, things improve as you refine your models. You get nearer to reality.
Well, I suppose from the way we're looking at this, you look at these objects, these moonlets, and you see a certain shape. But then you can look at an asteroid or a comet, and they've got some of those bizarre shapes as well, and they get bumped around a lot. So
that's right, yeah.
It stands to reason it's a widespread phenomenon.
So just going back to your vegetables, many asteroids are potato-shaped, but a lot of them have got this sort of dumbbell shape. There's two blobs joined together. That seems to be because sometimes they collide, but they collide very gently so that they just stick together by their own gravity.
All sorts of weird stuff going on out there.
Yeah, weird stuff, that's right.
But the more we observe, the more we learn, and the more we're able to potentially answer questions. I won't say we absolutely answer them all, otherwise we'd know what the wow signal was.
We would, yes, and a number of other things as well.
Yes. You're listening to Space Nuts. Andrew Dunkley here with astronomer Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Last, but by no means least, because the word epoch is in this question, we are going to focus on something that's been brought to us by Jacob in Brisbane. Hello, Jacob. Thanks for the question. And Look, I love this, Fred. He starts off with this line: "Hey, fellas, love the podcast. You inspired me to get a proper telescope over Christmas." Oh,
yay!
That's so nice.
It is fabulous.
Can I return? Now, just a couple of questions about the Big Bang and the inflationary epoch. Gosh, I love that word, epoch. I don't know why. Maybe when I was a kid, I played a thing called Epoch Soccer Game. But that's it. If nothing can move faster than light, is there an explanation for this rapid expansion being able to do so? I think we've been down that road before, but we're going there again. And Would we be able to tell if there was already matter in space that our universe now occupies, like an already existing universe that was pushed away, or was it definitely empty? Great questions, and good luck, Fred.
Well, thank you very much. Thanks, Jacob. I hope the telescope's performing as well as you hoped it would. They're great questions, and you've asked two questions which are neatly dealable with, if I can put it that way, separately. So the inflationary epoch, epoch's a great word, Andrew, and we usually use it to describe very long periods of time within some even longer period of time. So the inflationary epoch was a long period of time. It lasted about 10 to the minus 33 of a second.
There you go.
It was very, very brief, but it was still an epoch. This is something that we believe and have good evidence to believe happened immediately after the Big Bang, something like the same time interval after the Big Bang. So the Big Bang happened, the universe came into being, and then over this fleetingly brief period, expanded by a factor of round about 10 to the 50. So that's one with 50 zeros after it. The reason why we think that, they're a bit complex, but it comes down to the idea that the universe is very, very uniform in all directions. It's pretty much the same, whatever direction we look in, give or take the odd galaxy or 10 or whatever. Nevertheless, the overall characteristics of the universe are the same. And so it must have been inflated to a large size before the expansion that we see today kicked in, and basically caused us to see what we see. And that's the idea of the inflationary period. It's nothing to do with the price of things going up, which is today's inflationary epoch, yes. Although that stopped as well. So the question is about the speed that the inflationary epoch achieved. And it is true that, if you imagine two objects within that inflationary epoch, their separation would increase at vastly more than the speed of light. But this does not contravene Einstein's special theory of relativity, which is the theory that says that nothing can travel faster than the speed of light. And every piece of scientific evidence we have supports that theory and says that, yes, the speed of light is the ultimate speed limit in the universe. Nothing, not even light, can travel faster than the speed of light. So how did the universe manage to do that? And the bottom line is quite simple, that Einstein's theory of relativity relates to things that are moving through space. So objects moving through space cannot travel faster than the speed of light, but space itself can do anything it likes, because it's the space itself that's expanding, and so it's not bound by any laws relating to relativity, and that's how that rapid expansion occurred.
So the things within the space are reacting to the movement of the space and to the gravitational forces thereupon, but exactly. They can't move faster than light, but space itself is independent of that rule.
That's right. So they're just being carried on, carried along by the expanding universe. In fact, we have something similar today, although it doesn't exceed the speed of light, but it's the expansion of the universe that makes we see galaxies receding from us, because they're being carried along by the expansion of the universe. So we still see the effect today.
Okay, so that's part one. I think you've answered part one of his question.
Part two. Would we be able to tell if there was already matter in the space that our universe now occupies, like an already existing universe that was pushed away, or was it definitely empty? So he's basically saying what was here before here was here. That's right. And there may not have been a before. One very prevalent theory about the Big Bang says that not only space and time were created, and matter were created within that explosion, but time also was created.
Time began at the moment of the Big Bang.
that's one theory. In fact, that's what relativity tells us. But some people like to think that maybe time was there beforehand. So there are other theories as well. But I think that the secret to answering this question is that all of the space that we see in our universe was basically in a single point when the Big Bang occurred. It was what we call a singularity. So there wasn't anything there beforehand because there wasn't any space beforehand. So the space has expanded in the last 13.8 billion years from that single point. And, what we see around us now was once upon a time compressed into a very, very tiny space indeed, in fact, a singularity. I think what Jacob is getting at here, and this is interesting stuff as well, is the question of whether our universe basically exists in a higher dimensional space. So if you imagine that there's a fifth dimension and our universe is expanding into that, which is possible, was there anything else in that fifth dimension before our universe came into being? The answer is we don't know. We really have not got enough evidence yet to know that. We can think of some ideas that might be able to test it, mostly involving gravitational waves and things of that sort. But it is possible that, there may have been another already existing universe in this higher dimensional space when ours popped into being. So we might have had to nudge another one out of the way. But at the moment, physics doesn't allow us to speculate any further on that.
And it starts opening up that can of worms again about multiple universes, overlapping universes, neighbourhood universes, or we're the only one universe theory. I mean, there's just so much speculation and just no evidence to back any of it up, really.
Yeah, all of which really has, it tends to turn you into a space nut.
Yeah, indeed. But we do love our space nuts, and Jacob, we do appreciate the question. And thank you for emailing us via sunny Brisbane. We appreciate it. And we certainly do love to get your questions, and hopefully we'll get them all answered. I know we've missed a few, but we'll have to do some catching up. I keep saying that, but we will get to them sooner or later, Fred, won't we?
We sure will, in some universe or another.
Yes, maybe in the next universe. Who knows? Thank you, Fred, as always. It's a great pleasure and great fun. And by the way, I want to say thank you to all the people who've given us reviews on iTunes. I didn't even know there were reviews on iTunes because that's how often I check out my iTunes account. I know I've got one, but and while I was looking for a question or for an episode for someone the other day, I just happened to go, I found all the reviews and I just started reading them, and quite often people say, don't read your reviews. But gee whiz, Fred, there were some glowing remarks, and your cat Mandu has got an incredible fan base, I must say.
We need to get him a Twitter account.
Yeah, he'd eat it. He'd probably eat it.
He probably would eat it, actually. If it was tweeting, he would eat it. That's absolutely right.
But thank you for all the wonderful comments. We appreciate it. It's fantastic to get that sort of feedback. We had no idea, did we, Fred, that people enjoyed it so much. We
didn't even know whether anybody was listening.
No, but now there's at least 20. We can double the number. It's fantastic. Fred, thank you. We'll catch you again next week.
Great pleasure, Andrew, and my thanks too to all our listeners, and all best wishes, and we will speak again soon.
Indeed. Fred Watson from the Australian Astronomical Observatory, and from me, Andrew Dunkley, thank you for listening. We'll see you next time on
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.